Okay, this is graphing of sine and cosine, and we're going to start with the basic sine of a basic graph of a sine. So I draw my little grid here. The amplitude of sine is 1 to -1, which means the graph is going to go up to 1 and down to -1 for its minimum and maximum for the range. And we're just going to put in one period is 2 pi. So write that out here to the side. One period is going to be 2 pi. So from 0 to 2 pi is going to be one period, and then the sine graph is going to repeat each period after that. Okay, so let's divide this into sections. Pi over 2, and this one would be 3/4 pi or 3 pi over 4. And so let's find ordered pairs here. So if the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2, this would be 3 pi over 2 down here. The sine of 3 pi over 2 is -1, and the sine of 2 pi again is 0. So those are our basic points in one period. So 0, 0, pi over 2 is 1, pi is 0, 3 pi over 2 is -1, and 2 pi is 0. So the basic sine curve is going to look like this. And that is the sine graph over one period. Okay? Most of your directions in your assignment is going to ask for 2 periods, so let's just work backwards here. -2 pi, -pi, -pi over 2, -3 pi over 2. And essentially, this same pattern keeps going. So this one's going to be 0, that one's going to be 0, -1 here, +1 here. And the same curve within the period. Notice at the period break, right here in the one period, this side and this side are the same. Then just to throw it back to function's odds, I flip it over the y-axis. 3 pi over 2 matches -pi over 2. So anyway. Let's go ahead and take a look at example 1. That would have been the basic sine graph. And let's graph g of x. This, by the way, is the sine of x. G of x is equal to 2 sine of x. Okay? So what's the difference between sine of x and 2 sine of x? Well, the 2 out here in front is essentially, this is a scalar. It's going to stretch the graph vertically up by 2. So this is going to change the amplitude to 2. And so now I'm going to go ahead and use the same grid. I'm going to do it in red. If I multiply all these numbers here by 2, the period is still 2 pi, but 2 sine x, this is sine x, this is x, so 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, 2 times -1 is -2, 2 times 0 is 0, so this spot stays the same. Now we go up to 2, this spot stays the same, go down to -2, and this one stays the same, so the red graph is 2 sine x, and essentially just stretches the graph out, but the way it looks is still the same. You take it over a second period, multiply each one of these points by 2, -2 pi is 0, -pi is 0, 0 is 0, -pi over 2 is -1, so it becomes -2, this point instead of 1 becomes 2, and I draw the graph, and you can tell that it is exactly the same pattern. So essentially, if I wanted to graph this and keep it going, I would just keep going up and down and up and down, where it goes through 0 at 0, pi, 2 pi, then continue 3 pi, 4 pi, 5 pi. It hits 0 every pi units. It'll hit 2 every 2 pi units of pi over 2. Once you guys go ahead and try number 43 there for y equals 3 sine x. Take a second, figure it out, press pause, and come back, see if you're able to get it right. Alright, so we're back. Again, for one period, it goes 0 to 2 pi. There's pi, pi over 2, 3 pi over 2. And I believe the directions on 43 again say 2 full periods, so we'll just go this way. Negative 2 pi, negative pi, negative 3 pi over 2, negative pi over 2. Any point that was 0 is still 0. So 0, pi, 2 pi, negative 2 pi, negative pi, those are all zeros. Anything that was a 1 for the basic sine graph, pi over 2 and negative 3 and 3 pi over 2, we're going to multiply by this 3 known as the amplitude. So this graph, it's going to look a little funny, but 1, 2, 3, 1, 2, 3. So pi over 2 is going to be 3, 3 pi over 2 is going to be negative 3, negative pi over 2 will be negative 3, negative 3 pi over 2 will be 3, and the graph is going to go something like this. And there's 3 sine x over 2 periods.